Thank you so much for being here. It's a pleasure being here at All Things Open, as you might have already experienced over the last day and a half almost. It's been a really, really great place to have conversations about all things open source, open standards, just learning a lot more about how developers think about things, how the developer relationships side of things have also grown, some really interesting case study discussions that have happened. So I'm super excited to sort of provide our own contribution to this conference and hopefully touch upon something quite interesting, something that brings you a bit of value over the course of the next 45 minutes. We're going to be talking about designing a composable API platform powered by open standards and a few open source tools, as you would see over the course of the next 45 minutes. Quick introduction, I am Buddha. I am a developer advocate here at Tyke. So for those who don't know, Tyke is a cloud-native API management platform powered by an open source API gateway. We are one platform for every protocol out there. So if you're working with any sort of APIs and want to make it production ready, you can essentially add security, observability, all of that good stuff and make it very, very easy for you to manage all of it. But that's not necessarily what I'm going to be talking about today, and at least not in my part. I'm also the board chair for the Open API Initiative, if that's something that you're interested in or are involved in, as well as a member of the GraphQL Foundation. So any sort of API-based conversation that's out there in the world, I'm usually trying to be a part of that in some form or the other, because there's a learning opportunity and hopefully a way to add some value there. Joining me as well is going to be Zaid here, who is one of my colleagues and a lead solution architect at Tyke. His section, don't worry, he will be up on stage in about 15 minutes time, where he's going to be taking us through an entire demo of how you can actually build out a composable API platform. What are some of the components around it? We'll explore some of these open standards that we'll be touching upon and some of the open source tools to go with it. Agenda for you, we're going to be starting off with a quick discussion about the need for API platforms, go into the need for composability specifically. It's something that's been coming up quite regularly, and we want to sort of touch upon the need, the value that it brings for the API world today. We'll look at how you can go about designing a composable API platform, some of the key metrics, key areas to focus on, how you prioritize things, and some of the key capabilities of an API platform as you go along as well. And then finally, the big main event of today is going to be about the demo where Zaid is going to be showing how to build that composable API platform for you. So hopefully, we'll get some questions at the end of it as well. Hopefully, we'll get some time for that too. But that is pretty much what's on the docket. Now, so let's start off with the need for API platforms to begin with. How many people in the room today have used or developed or designed APIs or doing that actively, maybe? Show of hands there. Pretty much all the room. That is perfect. Not surprisingly, then, the metrics from last year showcases that web traffic in 2023, about 71% of all of that web traffic was just API calls. And at an enterprise level, that looks like 1.5 billion calls taking place on an average. So APIs pretty much rule the world in many forms, many fashion, many protocols out there. But we need a way to make and develop and build those APIs a bit more reliably, a bit more securely, a bit more scalably. And that's where we get to these different challenges, where building APIs is not very easy. It's not just about the functional logic anymore. It's also about considering the operational side of things, the things like security, the things like observability, governance, the discoverability of it, the overall experience of how developers are interacting with your APIs. And that's also equally important as much as building out that functional logic. To add to that, you also have to think about things like distributed teams and how you're going to be managing all of that, your changing and evolving needs of your businesses, and an ever-expanding tool stack. So with that, the solution to some of these problems, if not all of these problems, tends to be something called the API platform. Some of you might be familiar with it. And at the heart, at the core of it all, an API platform is a platform that enables developers to build and manage API products better, faster, efficiently. Very tool-centric, solution-focused definition, in my opinion, and it sort of misses a key element here, which is how do you bring people together? How do you make sure that things evolve, the platform evolves as your overall business needs evolve at the same time? So for those purposes and keeping those things in mind, I have a slightly different definition of what an API platform actually is. It is a composable ecosystem of intentionally designed APIs that empower developers, partners, customers to deliver desired outcomes. I think that last part, and perhaps the first part, very, very important. And we'll touch upon the composability side of things in the next couple of slides, but really the desired outcomes and being able to deliver those both at a business level, as a team level, and to your end users, which might be developers, partners, and customers, are very, very important, and something that actually a lot of people miss out and do not consider when they are building out their API platform or even creating API platform teams. So very, very important there. Now, let's talk a little bit about the need for composability and open standards. I'm going to take you through a bit of a journey of an enterprise level. For a company that is building out APIs and API products, some of the steps or milestones that they might encounter on their way. Perhaps this is a decade-long journey, perhaps in some cases. For some people, it might be about a 5-year long. So starting off, things are very, very simple. When you're usually starting off, you've got a couple of capabilities, perhaps a monolithic architecture. Things are small, teams are small, deployments are fast, not too much fuss, not too much complexity. Life's good. But then, now you've done a very, very good job of it, and now suddenly you've got users, you've got customers. They're asking for new things, they're asking for new features, they're asking for new capabilities. So then you start thinking about, okay, how do we make things a little bit more efficient? And you suddenly take the dive into the world of microservices. Good in a few ways, not so good in a lot of other ways. So, we can have a discussion about that at some point as well. There might be acquisitions that you might have done along the way. You might have moved to the cloud because you want to be closer to your audience, closer to your end users. You might have gone multi-channel because you're no longer looking at just a single protocol, but you're also thinking maybe GraphQL, maybe gRPC, maybe event APIs or async APIs are going to be valuable in this case. Your security requirements have now expanded because the surface area of attack has expanded significantly. So these are some of these milestones that tend to be typical for large-scale organizations and enterprises. So if I were to summarize all of this into sort of increased complexities, it looks something like this, where you look at things becoming a little bit harder to discover when it comes to APIs. There is a higher surface of attack from a security standpoint. It's hard to troubleshoot issues because now you've got a very expanded tool stack. You've got no standardization with these different distributed teams. Tends to be typical with a lot of these organizations again. And then the kicker of it all is scale. Now, if a problem exists when things are small, at scale, things get magnified tenfold and gets even worse as you go along. So you're almost paying for your own success, which you don't want to be the case. Not actual sites from Tyke or people not having API platforms, just as a caveat, but a lot of times things can look a little bit like this. So with that, let's talk a little bit about composability. Now, when you're starting off simple, things can be very easy. The choices can be a lot more simple at that point of time, but you do have to consider a couple of things. Because when you think about the maturity or the evolution of your overall API product's needs, then you need to think about those evolving changes and perhaps need for dedicated systems and solutions. You might want to go down the path of an IDP or identity provider when it comes to security. You might have to go into business intelligence tools for your analytics, maybe certain troubleshooting capabilities that are brought together by other observability tools as well. Now, you have two options at that point. If you have started with something that is perhaps not open standards focused or is not really composable in nature, you might either have to go rip and replace things, which can be very expensive, especially if you're locked into a specific vendor ecosystem, or you're stuck building pretty much custom integrations for every single one of these different components and then having to manage that as you go along as well. So you definitely want to avoid that because then you're not only, while you're trying to bring a bit of flexibility, you're actually adding a whole lot of complexity, which we don't want to get into. And obviously, vendor lock-in, never a good thing. So the solution to all of this is typically building out a composable API platform that is powered by open standards, makes it a lot easier to integrate with different solutions, different platforms that exist today, and makes things a little bit more flexible when it comes to the longevity and the evolution of your platform's maturity. With that all said, let's talk a little bit about the designing of a composable API platform. Remember, we talked a little bit about bringing people together and people also being an important aspect, whether it's internal stakeholders or external stakeholders. Well, one of the best ways of doing that is to be able to unite people towards specific outcomes. And when we talk about API platforms, there are certain metrics that tend to stand out. Yours might be different than mine. So here are a couple of things I'm going to touch upon. I'm going to start off with the strategy metrics and the metrics that matter, followed by implementation and then evaluation. Within this, let's talk a little bit about what good actually looks like. And I've sort of categorized things into 3 different buckets, starting off with productivity, going into cost savings, and then developer happiness. We'll touch a little bit upon each one of these. When we talk about productivity, it could encompass a lot of different areas or elements sometimes, but the idea behind it is how do we ensure or enable developers to actually accomplish tasks in the fastest, most efficient possible way? That's literally the crux of it. Now, how you measure it could be in a few different ways. Now, let's talk about self-service, for instance. How easily are people or your developers able to orchestrate different APIs? How easily are they able to get the job done without having to raise tickets for your platform teams to handle? How easy is it for them to troubleshoot or get to the heart of a possible problem that's coming in? You could also think about deployment times and how do you reduce that, release cycles, and how do you make that more efficient? So certain metrics around productivity that could be quite valuable. Cost savings, by virtue of standardizing against certain things, you no longer have to maintain 10, 15 different system solutions out there which practically perhaps do the same thing. You don't really need to do that. Really, really big cost savings, as well as from an efficiency standpoint, indirect cost savings there too. And overall developer happiness. How is the experience of your platform? How are they how are they interacting with the platform to be able to, again, get that job done? Measure that, perhaps an NPS, internal NPS score, net promoter score for developers, and how easy they find and how much adoption you are seeing with that platform as well. One of the other ways in which you can almost get to this and again unite those people together is something that we call the API Platform Roadmap workshop. It's built on the API Platform Engineering maturity model that looks to assess an organization or team's current level of maturity and hopefully create a roadmap for the future by prioritizing specific aspects or areas to focus on over a 6 to 9 month period of time. In practice, it looks something like this. This is usually a 90-minute session that we would usually run. But again, your method could be different, but the idea is to get to the point where you are able to understand some of the key drivers behind why the platform exists, some of the KPIs around it, as well as get to a level of prioritization that you want to focus on, and then finally decide on how do we get there in the next 6 months. So that's kind of the objective here. Going into implementation now, I'm not going to be prescriptive about specific technologies and just using those as you go along. We are talking open standards and open source to a point here. So if we go back to that slide of increased complexity across these different areas, we talk about hard to discover APIs, surface area of attack, troubleshooting issues, and standardization. What that maps back to in terms of capabilities of your API platform looks something like this, where you now think about your discoverability and design and how easy can you make that, your security and how robust can you actually make that, observability and how easy is it to get to the heart of a problem as quickly as possible, as easily as possible. Do you have centralized governance mechanism that makes sure that these distributed teams are adhering to and being enforced to actually create products that are not out of the extraordinary, essentially. They are essentially building things that adhere to certain standards, but at the same time have the freedom to innovate as they go along too. Now that further correlates to certain open standards, which is hopefully what we're going to be showing today, where when we talk about discoverability and design, one name that comes up, Open API specification, something that definitely worth considering as a blueprint of your entire surface area of your APIs. For discoverability, portals can be quite good as well. Again, there are a couple of options out there, internal as well as external. Security standpoint, OAuth is a good way of thinking about it, perhaps combined with OIDC in certain cases. Observability-wise, OpenTelemetry, big fan of OpenTelemetry. There are a couple of talks I've heard here as well, and really something that if you haven't considered for distributed tracing, definitely worth considering. And centralized governance as well. I mean, Open Policy Agent is one of those things that you could do, but any kind of policy engine that can enforce certain kind of fine-grained governance policy management, that's the solution that you would want to go for. And then finally, a composable API management or API gateway that sort of brings it all home, ideally, as a mediator between all of these different dedicated solutions that are hoping to achieve dedicated solutions out there. But ultimately, you don't want to be managing each one of them separately. You want a mechanism that brings it all home and together. The final step here is also about evaluation and iteration. So, a platform is never really complete. It's not a one and done thing. It's always iterative in nature. You always need to have open channels of communication and feedback to understand what your developers are facing. Are they adopting the platform? If yes, great. What else can we do? If not, how do we actually go about making it a little bit better? So that evaluation and iteration process is very, very key in obviously making that API platform that scales over a period of time and evolves as your organization's needs evolves as well. What it could also look like in terms of, and this is the final part that I'm going to be touching upon, which is success. What does actually success look like? And these are metrics that we have already seen with some of our end users and customers that have been able to achieve. So this is not the end state. This is essentially where a lot of these organizations end up beginning, where their release cycles might be in 6 to 8 months long time. There might be average deployment times that might be going to 4 to 5 different hours. Additional costs, again, by virtue of no standardization and things that they might just not be focusing on enough, could be in hundreds of thousands of dollars there, which if you then map back to a successful API platform and what it could accomplish, your release cycles can be whittled down from months to weeks. Your average deployment times from hours to minutes, and cost savings, thousands of dollars plus. And who doesn't want that, obviously? So with that, I'm going to stop here, hopefully, for pretty much the main event, hopefully for today. Moving on to the demo section. Over to you, Zaid.
Thank you very much, Buddha. Can you guys hear me? Awesome. I don't need the clicker, thank you. Just need that. And please be patient with me. I have 2 hands. One of them is occupied by the mic, so I do apologize for that. All right, you guys can see the screen here. So what I'm proposing here is to build a system that will allow us to use open standards and open source tooling to create an API, a composable API platform. So this is really complex. Obviously, we're going to break it down into different sections and discuss each of these sections and actually go through a demo that is going to use an open API spec that's going to be generated by me, the API developer. We're going to go through the take operator to generate the API intake, and we're also gonna expose that API through take. Now, once you expose it through take, we're gonna leverage Keycloak to do authentication for us, or we're gonna use the OAuth 2 flow with Keycloak. And last but not least, once we make a request, the request is going to hit the gateway with your key. Take is going to authenticate it, and at the end of it, once the request is back, it's going to ship all the metrics, logs, and traces to the Grafana observability stack. So as you can see, I have Prometheus, Grafana, and Loki, as well as Tempo. Are you guys familiar with those Grafana products? Show of hands, who's familiar with those? Okay, just to quickly explain them. Prometheus is used for metrics, Tempo is used for trace collection, and Loki is just for logs. And all of those will be exposed through the Grafana dashboards and exploration pages. All right, so this entire platform that you can see here has already been deployed on my Minikube cluster on my laptop. So this is all done using Argo CD. So you can, as you can see, I have a bunch of applications here already running on Argo CD. And all of this is available online. So if you guys are interested in running this stack on your own computer, there are instructions here on how to install all of this on Minikube, how to start on Minikube, install Argo CD, and run the entire stack. So I'm going to go ahead and close these 2 for now, and we're going to go back to the beginning. Oh, move this one back in. There you go. Whoop. All right, doesn't like me, but there you go. So this is what we're going to start off by doing, as I said, all the examples are on the repository, so don't feel like you have to take notes or anything. We will share all of this with you after. I don't know why it's saying Azure portal here. That's not the URL, but that's fine. All right, so the first thing that we're gonna do is I'm gonna take a look at my Golang. Can you guys see this? Is that too dark? All right, let's see. Yeah. Is it possible to switch to light mode through here? So just give me 1 second. Light mode. Oh, light mode doesn't switch back to this. So fortunately, yeah, we could also, hopefully, if light mode was picked up by this. No, it was not. All right, let's actually take a look at some of the examples through here. So we'll take a look at them through Source. All right, Notebook might work. Let's see. So we'll open with dot, and we'll go into examples, users, and let's see if Notebook will look nice enough for us. That's more reasonable. Sorry about that. All right. Yes, absolutely. Better? Good. All right, so sorry about that. So the first thing that we're doing here is we're creating an open API spec that is based on a service called users. So this user service is just a very basic open API. It has a /users. It's going to return all the information about the users. It's going to have a /users/ID. It's going to return information about a specific ID. And as you can see, the component section contains all the different aspects of the schema of that API. Now, the last section here talks about the X-Type API gateway. So the Type API gateway section is there to allow the gateway to understand how to deploy this API. So you're telling this to the API gateway, hey, here's the upstream URL. This is where you reverse proxy this API to. Here's the listen path. Here, that's where you will listen on for this API, so you can reverse proxy to it. And one thing I want to mention here is this plugin config part. So this is just some custom data that I put in here. This is going to allow me to use OPA rules to say, hey, if the OPA rules finds that that the auth value for this plugin config is set to keycloak, this is going to apply the keycloak authentication automatically. So as you can see here in the open API definition, I don't have anything that enforces authentication. So let's quickly show you what the OPA rule could look like. And security, OPA, and again, I do apologize for this. It was not planned. All right, so we'll open this up. And as you can see, I don't know if you guys are familiar with Rego or OPA, but the idea here is with Rego, all you have to say is, if those three statements pass, whatever those statements are, I want you to do an action. I want you to apply this policy. And in this OPA policy, what I'm doing is I'm injecting the keycloak credentials to allow authentication for my API. Now, if you guys are familiar with OAuth 2 or keycloak, there's something called the JWKS endpoint. This is what I'm passing in here. It is base 64, but we'll actually take a look at that endpoint in a second. All right, so this talks about the API and how it gets created, and we're not gonna look at this anymore, so we'll minimize it. And we're gonna take a look now at the rest of the example here. So, if we go back to users, perfect. Now, I just wanna take a quick look at this app.yaml file. So this app.yaml file, and we'll zoom in, is just basically going to describe my CRD. So if we go back to our diagram, and this is getting harder and harder the more I open tabs. So if we go back to our diagram, we have created the open API spec part, and now we're looking at the CRD. So the first part that I'm showing you here, let's close this, is the CRD itself. So a CRD is a custom resource definition. This is how you interact with Kubernetes and extend it. And as you can see, I have a CRD for the API definition. I have another CRD that describes the security policy. So the security policy is just a way for you to limit access to your API. And the last two sections here are pretty straightforward. You got your service that's going to expose your users, and you have your deployment. And this is just simply creating that deployment, the service, and it's also passing the service this OTel exporter, OTLP endpoint, and this is going to allow it to push traces to OpenTelemetry. All right, so we've done a lot of looking at YAMLs, so I'm going to close this, I'm going to close this, and let's show you what this looks like in the tag section. So right now, as you can see, I don't have any services. So if I go into, I guess I do need to go back into this, and I'm just gonna kubectl apply -f, and we're gonna go to the examples folder, and we're gonna deploy that user's endpoint. So if I go ahead and hit send, as you can see, if I refresh this, now I have this user's endpoint. It is created as an OAS API. You can see the upstream here, you can see the listen path, and you can actually see the keycloak settings that we have in here. If you take a look at the OAS definition, it has changed, and it now includes all the keycloak strings. So now that we have deployed the API to our gateway, the next step is to take a look at Keycloak and see how we created users to allow Keycloak to generate JWTs on our behalf so that we can access our API. So I don't know if you guys are familiar with Keycloak. It's an identity provider. Okta is another identity provider, or Auth0, Azure AD is another one. And they basically all do the same thing, with the caveat that Keycloak is open source, and it has been recently adopted by the CNCF. I believe it was April of this year that this happened. And let's go ahead and log into my Keycloak instance. And I'm not going to delve too deep into Keycloak. The two things I really want to talk about are, first of all, realms. So Keycloak has this concept of realms where it allows you to create different profiles, manage them completely separately to manage your authentication, authorization, and just being an identity provider. Now, one of the beautiful things about the the realms is the fact that you can actually export the entire realm definition. So once you create this realm, you can say, hey, I want this many users, these groups. I create my whole IDP platform, and then I extract that into a CRD using Keycloak. And let's go ahead and show you what that would look like. So if we go into resources, security, Keycloak, and we can see the Keycloak realm definition here. So let's zoom in here, another YAML file. So this just basically describes all the different resources that belong to my Keycloak. And this is beautiful because, hey, if you want to implement everything as infrastructure as code, well, it will allow you to do that. And again, this is all open source, which is unbelievable in my opinion. As you can see, I have a few users that I added here. And the rest of the definition. So let's see what we have done in Keycloak. The first thing that we have done is create a client. So to do any kind of OAuth 2 flow, you need a client ID and a client secret. I've also created a bunch of users and groups, and that's what I'm going to leave it at with Keycloak. So we have created all of this stuff inside of Keycloak, and now we can actually go to the next section, which is generating a JWT through Keycloak and allowing Tyke to authenticate based off of that JWT. So we already created that user's API, and now I can simply just go into my terminal, and as you can see, I already have a JWT. I'll generate another one, and we'll grab this. We'll copy it into two different places. So the first place we want to copy it into is this jwt.io, and we're going to come back to this in a little bit so we can see what's inside this JWT. We're also going to go into Postman. So with Postman, what I'm going to do is set the authorization header. So if I send this request, it's going to say authorization field is missing because it's expecting something. Let's just put anything in there. It's going to say it's not authorized. And once I put a real key in there and hit send, I get data back. So now Taiko was able to, and let's actually take a look at the diagram. It's probably best to show you this there. So what happened is the consumer went to Keycloak, they generate a JWT, then they use that token as part of the request to Taik. Taik then reaches out to the JWKS endpoint in Keycloak, says, hey, I have this JWT, can you give me an RSA public key to validate it against? Taik then fetches that, validates, and then applies authentication, authorization, and processes the request. So with this user's API, what we did was we gave anybody that has access to Keycloak or that can generate a JWT access to our entire API. Now, what happens if you want to segregate that further? So there is a reason why I pulled this JWT aside, and that is because I wanted to show you this field at the end. So the group field is something that I added. It's a custom scope. You can do that through Keycloak. And what I'm doing here is I'm injecting that value in here. And let's go back into Taik. And I'm going to use a different example for this specific use case. This is a Star Wars example. It's a GraphQL endpoint. I'm not going to delve too deep into that. But what it will allow you to do is map different authorization policies based on the scope claim. So as you can see, the scope claim is call group. If the claim value is admins or developers, then I'm going to apply different security policies. If we go into the policies section, I'm not going to go into the admins one because the admins one will give you access to everything, but I will go into the developers one. And if we click in here, you can see how Taik is applying that authorization authentication. Now, again, this is specific to GraphQL. So we are allowing you to authenticate or authorize based on the graph itself. So you can choose which parts of the graph this user has access to. You can also do depth space limitation, all that fun stuff that's associated with GraphQL. For REST APIs, you can do the same thing with pass. So it works the exact same way, but the restriction that you can apply is different between those APIs. So now that we looked at this, we can actually test things out. So if we go into our Postman, I have this Star Wars API request. It is currently requesting a person. So if we quickly just go back here, as a user, I'm only allowed to access the species and person objects of a graph. So I'll go ahead and hit send. It's going to tell me, hey, the user is Luke Skywalker. So you can see that I got a response from this one because I am using the admin API, the admin GWT. If I send this one as well, it's going to say authorization field missing. So let's go ahead and add that. So we'll copy this. Oh, too many white windows open, don't know which one to go to. And we'll hit send. So now you have access to Tatooine. So as an admin, you can do all of that. So let me grab a key that is based off of a developer. So as you can see, actually, instead of continuing to go up, I'm just going to use or change this value to developer. There you go. And now if I grab this JWT, I can toss it in here. And if we hit send, it's going to tell me that you don't have access. So based on the scope that is inside of your JWT, Taik was able to determine the access for the user. All right, so now that we did all of this, we're coming close to the end of this. The last part of the journey is the observability part. So with this, in this diagram, all I added was the OpenTelemetry part, Prometheus, Tempo, and Loki. And we can take a look at all the requests that we have seen go through our service and see traces, logs, and metrics based on that. So if I go into Grafana, I can take a look at my dashboard. So I already built 2 dashboards. Let's see, does this look? Okay. Pretty sure there was, anyway, sorry. I'm sorry about the, the dark theme, obviously. But as you can see, there's some metrics here that's actually being shown based on your traces. So based on the traces that are coming back from OpenTelemetry and being collected through Tempo, I'm able to create different dashboards based on that. This is a little bit more visible, but this one is actually based off of your metrics. So this is based off of the metrics that is coming through Prometheus. So you can combine metrics, logs, and traces, and based off of those, you can generate graphs that gives you observability into your system. Now, the last thing I do want to show is the Explore page. So in here, we're actually going to take a look at some of the traces that that some of the requests that we created, that we ran generated. So if we search by git/users, so this is the request that we have made through Postman. And as you can see, there are a few traces associated with it. So if we dig further into those traces, we can actually see what happened. So all the traces are actually associated with Tyke except for the last one. So this is distributed tracing, where some traces are coming from Tyke, some traces are coming from the user REST service, and it's generating a full picture for what actually went through your platform. Just want to show one more example of multiple services that are connected to each other. So as you can see here, this is a trace from one service that is calling many different services. It's calling the user service, the post service, the comment service. All of these services are being called, and you can see the trace for all of that. So in here, we were able to create an API using using OAS. We were able to secure it with applying an open policy agent rule. And then we were able to secure it using OAuth 2 and Keycloak. And last but not least, we were able to see all the data that's coming into our platform from traces, logs, and metrics. And that's all. Thank you so much.